We can create value driver trees to help us with various planning scenarios. In this example, we'll create a value driver tree to project the sales of apparel and footwear products using different combinations of possible growth rates. Note that in our model, we've added a growth rate driver, which we'll use in the calculations of our value driver tree. In a table, we've created a forecast that includes a set of possible growth rates for apparel and footwear products over the next several years. The value driver tree we create will calculate the gross sales values for each of these future periods based on the growth rates we've entered. Now we're ready to create our value driver tree process. First, we need to give it a name. Next, we'll specify the underlying model. On the Time and Model tab, we need to set the start and end dates for the calculation and presentation periods. The calculation settings control the time periods that are used to calculate values, while the presentation settings determine which time periods are shown when the value driver tree displays in stories or digital boardroom presentations. Note that currently, only the default period duration of year is supported for both calculation and presentation. We'll set the calculation start date to 2018, as this is the first year we need to forecast. We'll leave the other settings with their default values. On the calculation canvas, we need to create the structure of the value driver tree by linking a series of nodes. Note that there's an option to auto-complete a value driver tree structure based on selected members of the account's dimension if desired. This is a useful starting point for complex tree structures. In this case, we'll create a tree manually, starting with a single undefined node. We'll call the node Apparel Growth Percentage. Next, we'll specify the node type. There are 4 different node type options. Data source nodes allow us to get data from the model, such as the values for the account member that we want to use in our calculations. Year-on-year nodes allow us to calculate yearly values for an account using a base value and a growth rate driver, and output the data to an account in the model. Union nodes aggregate the values from 2 or more other nodes. Simple calculation nodes allow us to perform basic arithmetic calculations using 2 input nodes. For this example, we'll start with a data source node. Now we need to choose the source account we want to work with. In this case, we'll choose the growth rate percentage driver from our model. We'll apply a filter on the product group dimension so that the node will bring in values only for apparel. Now we'll add another node. We'll call this one Apparel Sales. This time we'll use the year-on-year node type. We can set the node to calculate on details or on aggregates. If we choose the On Details option, separate calculations are performed for each leaf member of the input nodes. If we choose the On Aggregates option, the values are aggregated from the leaf members of the input nodes before the calculations are performed. For this example, we'll use the default option, On Aggregates. Next, we need to specify the base, driver type, and driver to use for the node. The base refers to the node that provides the base value for the first year of the year-on-year calculation. By default, it's set to the year-on-year node itself. The driver type determines the type of year-on-year calculation to apply. Growth rate is the only available driver type. The driver refers to the node that provides the growth rate data for the calculation. Here, we need to select the Apparel Growth Percentage node. Note that after we set Apparel Growth Percentage as the driver, the Apparel Growth and Apparel Sales nodes appear connected, indicating that the values from the Apparel Growth node will flow to the Apparel Sales node. In the output area, we need to specify the account to which we want to write the value calculated by the node. In this case, we want to write to the gross sales account. Finally, we'll add a filter to ensure that we write values only for the products in the apparel category of the product group dimension. Here, we've just added another set of nodes, this time for footwear growth percentage and footwear sales. Now we'll add one more node to sum up the projected sales for apparel and footwear. We'll call this one Combined Sales, and we'll use the union node type. In the Inputs area, we need to add each of the nodes we want to combine. First, we'll add an input for the apparel sales node. Next, we'll add an input for the footwear sales node. The combined sales node is now connected to the apparel sales and footwear sales nodes. Note that in the input accounts and filter areas, the appropriate values are set by default because they're inherited from the input nodes. The value driver tree is now complete. Before we run a simulation to perform our calculations, we'll set up the consumption canvas. Here, we need to specify which nodes will display when users work with a value driver tree in stories or digital boardroom presentations. The separation between the calculation and consumption flows allows us to create structurally complex value driver trees, but to hide the unnecessary details from users and make the trees easier to work with. From the consumption canvas, we have the option to copy the whole calculation flow if desired. From the calculation canvas, we can select a node and then either add the node or its whole branch to the consumption canvas. In this case, we'll copy the branch. The consumption canvas now displays all the nodes from the calculation canvas. If desired, we could delete nodes and link or unlink nodes to change how the tree displays. Note that removing nodes and changing links in the Consumption tab doesn't change how the values are calculated. It only changes how the tree appears to users. Now we're ready to perform a simulation. We need to choose the version on which we want to calculate the values. For this example, we'll choose the VDT forecast version. Note that the 2017 values from the model now display in the combined sales, apparel sales, and footwear sales nodes, and the apparel and footwear growth percentage nodes display the values we entered in the table. Now we're ready to run the calculation. The values for 2018 through 2021 have now been updated in the apparel sales, footwear sales, and combined sales nodes. Note that we can open the Examine panel and select a node to view or change its values. We'll change the footwear growth percentage value for 2021. Note that the value in the footwear growth percentage node has also updated. We can run the simulation again based on the new growth rate if desired. Thanks for watching.